Okay, we're live.
Okay, cool. Thanks everyone for coming tonight. And as you know, I'm a principal engineer here at Just Eat, and we've got a couple of guys on the online as well on the Hangout. And those of you on the Hangout, if there's anything wrong with the audio, please let me know. I will try to stay closer to the microphone. So for the last couple of years, I've been working very closely with Amazon Web Services, and I have used quite a lot of different services that they provide. And in doing so, it's given me an insight into some of the complexities and challenges that arise when you try to integrate your application with the cloud. And the problem is not limited to Amazon, and you find similar challenges in the other cloud providers as well. And complexities of three common types, be it the libraries and tooling available to you, doesn't provide the sufficient level of abstraction for you to easily work with the service. And sometimes the API the service provides to you is also too simple. So you end up pushing some of the complexity to you as a consumer of the service. Or perhaps the service is just not designed to support some of the more advanced use patterns and the needs that arise, that emerges in the wild. With this talk, we use three of the services that Amazon provides as a case study, and with this, I hope to give you some inspirations on how to identify these complexities and how you might be able to use DSLs to tame such complexities.
Yeah, if I may
along the way, we'll see how.
Do you mind sharing your screen on the Hangout as well?
Oh, okay. You did not share it on Hangout?
I can only see like a part of the screen up there. Sorry for the interruption.
Okay. That's all right. Glad you interrupted. Otherwise, I'll be really boring viewing for it online.
Brilliant. Cheers.
How about now?
No, that's great.
Okay, cool. So along the way, we're going to see how F-Sharp is an awesome tool for building these DSLs with. Be it internal DSLs, which are just APIs that speaks with the concept, that works with concepts from your domain, or external DSLs, which normally comes in strings, so you have to parse them as well. We will start with DynamoDB, which is the fastest growing service that Amazon has. It manages the key value store with built-in redundancies and 99 guarantees, and everything runs on SSD, so you get very fast as well as very predictable performance, typically in the single-digit milliseconds for both reads and writes. And unlike most other services that Amazon provides where you have a pay-as-you-go model, with DynamoDB, you instead name the throughput you require for your table, and you pay for the amount of resources that Amazon have to reserve in order to meet your throughput needs. So for example, if you want to create a table that can do 10,000 reads and 10,000 writes a second, you just fill in a few boxes, and then that's it. After a few minutes later, the table is there, and you can change your throughput requirements on the fly without any downtime, and you pay for the amount of resources for the duration when you need them. So it's just as easy for you to create a table that can do 10 reads a second as it is to create a table that can do 1 million reads a second. So you can create, there's some very nice use cases that come out of this. One of these examples I heard is advertising agency that does pretty much nothing all year round except for the 4 hours of Super Bowl, during which they're doing something crazy like 4 million reads a second, and they manage to get away with it for about a few $1,000 without having to build and maintain a very expensive infrastructure. They can handle that kind of peak load and just not use it for 99.9% of the year. And in terms of the schemas, the only thing you need to provide for the data is a hash key, which determines the physical grouping of your data, and optionally a range key as well, which allows you to perform queries against your table. In terms of query in DynamoDB, you specify the hash key, and then provide some condition checks, filter conditions on your range keys. You also have indexes. You have a local secondary index, which allows you to specify an alternative range key for your table, or a global secondary index, which allows you to specify a second set of hash and range key for the whole table. So as an example on how you would use it, here I've got a table that stores the scores of players in different games. Most of the time I'll be writing data based on for a particular player and a particular game, so I'll put my range and hash key on the user ID and the game title. But sometimes I want to find out, for example, who are the top players in a particular game. So I will have a global secondary index where the hash key is on game title and the range key is on the top score. And sometimes I want to find out what are the top 3 games for a particular player. So I will have a local secondary index for the game score as a range key as well. You can also perform full table scans, but these tend to eat up your throughput and can impact your other write and read operations, and they usually take quite a long time to perform as well. It's a very nice database to work with, and I think we use very heavily here at the Just Eat as well as my last job. The thing I don't like about the database is the amount. If you look at how much documentation there are to describe the query operation, which tells you there's a lot of different options and different tweaks for you to work with. So when I want to ask a simple questions such as, give me the top 3 players in Starship X whose score is at least 1,000, I end up writing quite a lot of code. Well, I mean, it's not a lot of code, but code that's not very expressive of my intent. I have to create a request object, I have to set some properties to describe the name of the table, the fields I want to filter on, the name of the index, and then to express my filter conditions, I have to create these condition objects and this attribute value, and then set the comparison operator, etc., etc. And even though it's only about 30, 40 lines of code, by the time I read the whole thing, I kind of forgot what was my question in the first place. Wouldn't it be a lot nicer if I can write something like SQL, something that's much more expressive of my intent of the questions that I want to ask of my database? And still, at the same time, not lose the ability to describe any conditions around what the index to use and whether or not to use consistent or eventually consistent reads, which is why I spent a weekend and put together a small DSL with the goal of disguising some of the complexities involved with the query and scan operations when you're working with DynamoDB. And another thing I found with my last previously is that because there's so much options, so much tweaks involved with the operations, it's hard for you to provide meaningful abstraction layer on top of it without actually leaking some of the implementation details from underneath. So again, another goal of this library is to prevent those such abstraction leaks. And I want to provide you with SQL-like syntax so that new developers coming into the team has an easier time to understand and start working within your domain without having to also spend all this time understanding the API that you have to work with when you're working against the DynamoDB. So to make this happen, you take a query, which is a string, then you pass it into an abstract syntax tree, which then you can then use to generate the request object that we had to write by hand before and execute it against DynamoDB and give it back the result. And to do this, for this case, I used the F# and fparsec, which is a port of the Parser library from Haskell. And it describes itself as a parser combinator library, which just means that you start by writing very simple parsers for flows for integers, and then you start composing them together to build more complex parsers. And the functions that does the composing, that's what we call a combinator.
Is this
Yep. Sorry?
Is that Parser in a
Yes, yes. So starting with a very simple example, we're going to turn that query into an abstract syntax tree. We can start by decomposing what the query is made of. You've got some keywords such as select and from. You've got table name at the end. And then for the attributes you want to select, you've got different two cases here, either a star, which is wildcard for everything, or a comma-separated list of attribute names. And for that, we can capture this, the two different cases in the union type, which you haven't seen it before in F#. You think of it as a more powerful version of enums in C#, where every case can be also associated with an arbitrary set of types. In this case, asterisk is just what it is, but for attributes, it's also associated with an array of strings representing the comma-separated attribute names. And for the whole query, we can capture all the information we need in a record type, which is just a very lightweight data container type. Think of this as a class where the properties are immutable, but you don't have to, you have a much lightweight syntax for expressing that. So to start off, we're going to build a parser for the keyword, in this case, a select keyword, and we can do that using one of the built-in parsers from fparsec called the skip string CI. And what you would do is you take a string that you want to match, in the case insensitive word, hence CI, and when it's matched, we tell you that, hey, it's a match, but it doesn't return any meaningful value. And we will do the same thing with the from keyword. And for the table name, we know from the documentation that DynamoDB requires table names to be only letters and digits. And in fact, actually, you can use underscore and other things as well, but I've simplified it here so that the code fits onto the slide. So we first build a predicate using the built-in its letter and its digit predicates from fparsec, and we combine them using a custom combinator which applies all semantics to two predicates. And then we can use another built-in parser called the many-one-satisfy, which will parse a sequence of one or more characters that satisfies the predicate function that we've passed in here. So now we have a parser that can take a string and parse it as a table name. So moving on, so now we have to deal with the attributes that we want to select, where we have two cases of either a star or comma-separated list of attribute names. And to parse the star, we can use something called in the parser called the string CI return, which is very similar to the skip string CI we saw earlier, with the exception that once the string has been matched, you will return the value that we provided. In this case, we provided the union case we specified before, called the asterisk. And for the other case, we want to deal with attribute, a comma-separated list of attributes. And first, we need to build a parser for the individual attribute names, which in this case actually looks exactly the same as the table because they have the same requirements in terms of only allowing letters and digits. But we also need to have a parser for the comma. And once we have both, we can combine them together using the separated sep by one parser from fparsec, which will parse one or more attribute names separated by a comma using the two corresponding parsers that we have created so far. And that gives us a parser that can parse a comma-separated list of attribute names. Now that we've got both of these guys together, we can again further combine them together using the choice combinator or this shorthand notation. What you do, you try to parse an input as using the first parser, and if that fails, you try to use parser with the second parser. And this will give us a parser that can parse the attributes that we want to select. So now that we have all the different parts we need, it's the time to combine them together once more. And this time, we'll use the tuple4 combinator, which takes 4 parsers and applies them in turn. And its result in this case would be the return value from each of these parsers in the tuple of 4 elements. But that's not very useful for us because we're not dealing with tuples, we're dealing with queries. So what we can do is we forward that tuple onto another function which would use an underscore, which in this case is a wildcard and say, I don't care what those values are, I'm not going to bind them to any variables, but I care about attributes from the attributes parser, and I care about a table name that's coming from the table name parser, and I'll capture those two and put them into a query object that we declared earlier. And that is how I can end up with a parser that is able to parse this simple query. And once I've got this, I can then incrementally add support for the where clauses and for the limit and order and with clauses so that I can incrementally add more syntax to the query. And once I've got some of the basic building blocks together, the actual query syntax itself, the parser for the query syntax took less than 50 lines of code. And it just goes to show how much you can do with not much code at all, and how much productivity you can get with using F# and the fparsec together. Nowadays, oops. Okay. So nowadays, Michael Newton, one of the members of the F# community, also put together a very small project called mParsec. So this is useful where, for example, when you are working on a type provider, you need to write a parser, but you can't depend on whole package because mParsec comes in as a package. So here, so mParsec gives you a very similar API to fParsec, but it's a one-file dependency which you can either grab it from a packet and inject it into your project, or you can just copy the whole thing, mix, and copy it into your project and make life a lot easier for you. So to recap, we looked at how DynamoDB's query and scan operations as examples of an API that suffers from under-abstraction, at least for .NET, and how you can use a very simple DSL to give you a SQLite syntax, and how you can easily build that with F# and fParsec. So with that, do we have any questions from the audience here as well as online? Yep, one question there.
What sort of error message do you get if it doesn't pass correctly?
Okay, so the question is, what sort of error message do you get if it doesn't pass correctly? So that's one of the nice things about fParsec is that where you do get an error, you get a snippet of the lines of code that's not matching with telling you, where you are in that query, so in terms of the column number and row number. So it actually tells you which bit of code is not matching and what is expected instead. So the error messages is quite nice. I don't know if it's the same. It's the case with mParsec as well. I haven't used it myself, but from the blog post that Michael Newton wrote, he's going after the same approach. So I imagine the error message will be quite similar as well.
So technically, because it's an unthinkable style, you should get all errors.
Not all errors. It's the first.
If you, sure?
Yes, I think so. I think it's only the first one.
So it's months.
Maybe.
Okay. So yeah, that's the nice thing about the style parser is that it does pass the whole thing, and that comes out with all the errors that it finds, rather than stopping at the first one. Whereas the monadic style, it normally is short circuit, so it would find the first error, blocks there, and reports on what the errors are.
Yeah, it's definitely the first error. And if you imagine all the errors that you can have, I don't know how that will work and how useful it would be if you get all the potential. Because the first thing that fails, that means that everything else is going to probably fail after that as well. You're going to get all kinds of nonsense error messages that's probably not going to help you very much. If that's the case.
It's used for validation.
For validation, it's different. So for parsing, I would say that's probably not very useful. For validation, definitely you've got different rules around. Okay, that's not a good email address because it's missing .com at the end, it's missing add, it's missing this and that. That case is very useful for that, where you can apply all the different validation rules and get all the failing ones back as error message. Whereas for parser, I would say you probably want to just get the first one. Any questions? Any more questions? No, cool. So we'll move on then. Okay, yeah, sure, of course.
I guess it's a bit more general concept question. Is there not a danger when you design a DSL like something else? So you're designing a DSL like SQL that people would expect things that aren't there. So if they're expecting things from SQL to be there, there's not a danger of that.
Yes, there is. There is danger, but at the same time, you also have. But at the same time, you also something that people are familiar with. So at least for the space use cases, most of the time, you're probably going to be doing select whatever from whatever where. So those basic building blocks is there, and sure, you might expect other things that's available in SQL, but not here. But I think you find out pretty quickly. That's where documentation comes in, and for this project, I actually spent a lot of time writing documentation just so that you know what are all the different optional clauses that you can add, for example. And a lot of that is all depending on what is supported by DynamoDB under the hood. So the syntax will only allow you to express things that you can do with DynamoDB. In this particular case, we're not adding any additional functionalities.
Could some of, to follow up that question,
Yep.
could some of this be done with computational expressions with custom operators, or is it not flexible enough?
It can. So the question was, can this not be expressed as a computation expression? Yes, you can. One of the requirements that I had at the time, and you still have, is that it has to work from C#. So that kind of makes it out of the question, out of the window. Another problem is that with computation expressions, you kind of need to know the schema, but with query it's okay because you know the schema for the table is hash key and range key. But for scan, you can do anything you want to. So that kind of make it harder for you to use computation expressions. There's another library called f#.dynamodb by Eric, who've been working on. So I've been working with on the AWS backend for Embrace. So as part of that, we had to do a lot of things with DynamoDB as well. And there's some use cases that came out from that, which made him actually go and wrote something that uses F# quotation to capture the query that you want to express as a quotation object, so you can pass it into, say, for example, that would be a greater operator, greater than or equal to operator, and construct the query object from that. So that is also a much nicer API if you're only working in the F#. But yeah, there are something that I looked at and experimented with, but because of the requirements I have in terms of having to work with C# and having to work consistently across both query and scan operations, I decided it wasn't a good approach. Okay, one more question.
Are you going to show us how to actually use the parser?
No, but I can show you afterwards. I've got some code examples that I can show you afterwards. Yep.
I'm just wondering how easy it is to sort of debug through this stuff.
Mm-hmm.
Like if you've got something that's not working quite right,
Mm-hmm.
like you're using that Parser library. How easy is it to sort of, because you're passing in a DSL and then you're getting out a query request object. Is it easy to sort of like debug through it all?
Right, so the question is how easy is it to debug through things when things are not working, either because there's an error in the syntax or because of how the query object the request object is constructed from your query, right? So the first part is normally you can rely on the error message from Parser, and they're quite good. From my experience, they've been clear enough for me to really quick to figure out what's wrong with the DSL. The problem when it comes to if in my library, if I'm constructing the request object incorrectly, then that becomes a harder problem to debug. But you can still use a Charles or Fiddler to capture the request that's going through to Amazon and then to work out what the problem is. And I did have a bug before where it was because I was using doubles. So for very large keys, you start losing precision. So for very large numbers, you actually end up translating it to the wrong value, and that happened. And that was something that was reported by someone who was using my library, and so that's what I did at the time, to use a Fiddler to see what request was actually being made to Amazon, and then work out, okay, right, that's the query, and that's what I'm generating from that query, and then work from that backwards.
Was that bug in your translation of the AST into query object? Go through the stages?
Yeah, well, yes, because I'm parsing it successfully, but because I'm using a float, it starts losing precision at very large numbers. So by the time I can't remember whether it was when I was parsing in the parsing part, or whether it was the translating to query object part. But I think it was a parsing part where it was able to parse it, but not the same number.
Because you have at least the opportunity to test your parser.
Yeah.
Because you can test the AST results before you do any translation.
Yes. And then the parser that I wrote was I wrote this little bot, this Twitter bot that would take a list syntax for math equation and then generate render images from that. For that parser, where I have for this AST, there was loads of value are not valid. Otherwise, for the other part, for the tweeted bot thing I wrote, because every expression is valid, as long as it can be generated, I can actually use the fs check to auto-generate the AST, go from that to the string, and then pass it back, and then check whether or not I'm getting the same AST object, which means I've got one test case that covers everything that I can ever think of. I can't really do this with this particular parser because not every value that I can generate from the AST is valid. So I'm having to write a lot of test cases by hand. But yeah, sorry, run about from the question. Do you have any more? Did that answer? All right, so let's move on then. The next service I will look at is Amazon Simple Workflow, which is which presented a whole different kind of challenges. It's an orchestration service which allows you to, which manages state for you, and as well as things around heartbeats, retries, and monitoring. And the way it works is that you write your own decision workers that will poll the service for tasks. And the task that comes back in this case contains information about the current state of your workflow and the event that's happened so far. And based on that information, your worker is supposed to tell the service, hey, now do the next activity, which could be, if you're doing payment processing, it could be talk to the payment provider via the API, or it could be, once that comes back, it could be send an email to the customer to confirm that the payment has been accepted, and so on and so forth. And this is also the guy that's responsible for determining whether to complete the workflow when the last activity has been completed, or to cancel it, or to fail. And you also need to write activity workers to actually do the work itself. And activity workers do the same thing. They poll the service for task, but in this case, the task that comes back contains a payload that tells the worker on how to perform the job they're supposed to do. So it's, for example, following the same payment processing. So example, as an activity to make to make the payment, or to make the communication with the payments provider, you may contain some security key, the URL you need to talk to, for example. Or if it's to upload an image, it will be, you contain the information on where to upload the image to and where to load it from, for example. And once the task has been completed, the activity worker will respond to the server to say, hey, this activity has been done. So then another task becomes available to your decision worker with a new event that says that previous activity is now completed. So the decision worker can decide whether or not to continue the workflow or to complete it, and so on. And because you've got this polling model, it means that you can have workers running from anywhere, from your own data centers, from the Amazon's web services, or if you want to be fancy, you can have them coming from Google and Azure as well, just to piss Amazon off. And you've got a management console that you can access that allows you to see all the events that happen on your workflow, as well as input and output. You can also nest. You can also from here retry any workflow that has failed, or nest workflows, and you can see your trial workflow and what happened there as well. At the time, I was evaluating this service for doing our nightly ETL process, which have to. So from the services that I was working on, everything you do in our game, I'm a backend developer for social games before, where everything you do in the games are recorded as an event so that we can run them through our analytics pipeline, and then BI guy can tell us what features are working and what not. So as part of the nightly ETL process, we will take all the events that's been saved in S3, run some aggregation on them, and then do a bunch of transformation, and then shove everything to Google Cloud Storage from S3, so that you can then, those data can then be loaded into Google BigQuery, which is the BI platform that we use, which is amazing, by the way. If you've not seen it, it allows you to write SQL-like queries against exabyte-sized data sets and still get data back in under, say, 30 seconds. So every night every day we were producing somewhere around 20 to 30 gigabytes of data, and every day we were running query, I think, consuming about 27 terabytes of data or something crazy. And every time, the BI guys can do everything by themselves without any of the without us developers having to handhold them and help them bring up machines and terminate and scale them down afterwards. So it's a great platform. The downside being that everything needs to go into Google's equivalent of S3. So we end up paying for compute as well as the data transfer. So back to a simple workflow. I was trying to evaluate the service for orchestrating our ETL process, and I started by, as you would, with how to write a hello world example. And behold, the amount of code I had to write just to write a simple hello world, which is pretty insane. And again, because of the sheer amount of code, and I haven't even done things like error handling and retries and heartbeat, the intention of what I had, the hello world workflow, is nowhere to be seen. It's just all lost in that whole sea of noise. And after I've done that little hello world example, I just went back and thought about what I did wrong and what happened. And I think what happens when you try to build an application on top of simple workflow is that you've got this very thin layer of API for the service, but underneath of all that, you have to implement polling, you have to do heartbeats and error handling, and those are your responsibilities. And once you've done all that, you still have to write your decision worker and your activity worker. So that's a lot of plumbing and a lot of infrastructure to have. You have to write just to get going. And the only thing that's unique for a particular instance or workflow you have is the activities that you want to perform on that workflow, right? Everything else is just glorified boilerplate. And this actually reminds me of something that Chris Jordan wrote a while back in the post called "The Complexity of Simplicity," where he talks about the notion of having good and bad simplicity, where good simplicity is being able to do more with less because you've got leverage, whereas bad simplicity is being able to do less with less. He went on to use the Google search box as an example for good simplicity, whereby it's one simple text box where it allows you to do so much more. You can search for movies, you can search for the current exchange rate, you can type in a math equation and give us the results. There's all kinds of things you can search, you can do with that tiny, very simple input box. And Stripe have done the same thing with credit card processing, which has traditionally been very complex. It's very nice. I think it's a very nice blog post which you can read all about. Following that link at the bottom, I'll share the slides afterwards. So back to the stuff that mountain of code I wrote for simple workflow. This is my decision work and logic here. So this is the guy that's responsible for checking the last event that happened on the workflow, and depending on what that event was, to either complete the workflow if the activity was completed, or if you failed, then fail the whole workflow. The problem is I can't possibly go from looking at that to seeing the workflow that I had in mind, which is having just one simple activity that prints hello, the name of the person that came in as input, because the workflow is actually implied by the logic you have in your decision worker. So instead, wouldn't it be nice if the workflow would drive the logic in your decision worker instead, or even better, if we just automate it? That is why I also spent another weekend. Actually, I think this one is a bit longer than a weekend. And wrote another small project called Amazon Simple Workflow Extensions, with the goal of removing all these boilerplates that you have to write when you want to work with a simple workflow, and allow you to write code that actually matches the way you think. So where I have a mental model of a workflow that I want to perform, now I can just hook them up, have an activity, have a little simple function that represents the activity that I want to perform, giving some input, and then the activity type that allows you to specify timeout and a bunch of other things for the activity, and then just attach the activity to the workflow using this arrow notation. So now, if I want to understand what this workflow is doing, I just follow the arrow. going from start to one activity, and once that activity is done, the workflow is completed. And just hooked up to my little simple function there. As you said before, simple workflow service allows you to nest the workflows together. So we'll support that in the DSL. At the top there, I've got another child workflow which I can attach to the parent in the same way that I can attach any activity to the workflow. And the library would manage the propagation from input to passing that. Taking the input for the workflow, passing it into the first activity as input, and then taking the output from the activity and passing them on as input to the next activity or next nested workflow. So all works very similar to the pipes operator you have in the F#. And also support the things like retry, so that you can retry a particular activity up to a number of attempts. And when that fails, you capture the error message and report it back to the service so that you can view them on the management console. So to recap, we looked at the Amazon Simple Workflow as a service that's perhaps too simple. So simple an API that actually end up forcing you to do a lot of the plumbing, a lot of the heavy lifting, and how you can use simple DSL to again manage and tame those complexity. Okay, so before we move on, any more questions from the guys here? So
the plus operator does.
Yes, so the plus operator just that's how you wire activities to the workflow, and where the activity have an exception. Because it takes your code, it just takes a function that you want that takes an input and returns an output. So it will execute. You generate a decision worker that will activity worker that will execute your code. If there's an exception, you capture that, report back to the server, and say, hey, this activity failed. And because we can say, okay, we want to attempt this activity up to say 3 times, the generated decision worker will also then see, okay, for this particular activity, it failed once, failed twice, failed 3 times. Now we fail the whole workflow because one of the activities failed more than the maximum number of times it's allowed to. The point is that you don't have to write that code yourself, and you can still just quite easily follow what's happening in the workflow. One thing you can do in the simple workflow service, but it's not supported here, is be able to branch your workflow. So, for example, if right now I've sort of implemented everything to cater a particular use case I had, which is quite simple, it's quite linear. But with a simple workflow, we can actually say, okay, based on some condition, I will execute a different activity in one case versus another, which is something that I'm not supporting right now. And unless someone, I don't think anyone's come up with that case yet. But if there's a need, it's quite easy to do as well. Yep.
Currently at work, looking at creating a distributed transaction.
Okay.
So when we register a user to our website, we have to write information to a resource database, an auth database, register them on Stripe, register them with another third party. That sounds like a really good fit for what you're doing. Do you think that would? And obviously, if any of those failed, we'd need to stop and roll back.
Yep.
Could you? Is that built in? And could it be easily adapted?
Right. So the question is, one of the guys is implementing registration process, which involve a number of things they need to register, and then when that fails, need to roll back. Right now there's no support for rolling back, but it's something that you can. I can. Actually, that said, what you could potentially do is have one of the activities, one of the workflows being the parent that kicks off the whole thing, and then you have a nested workflows, which means for individual steps that fail, you can retry them from the console. Or alternatively, you can have the child workflow that performs all that step, and at the end of it returns an option or a choice that tells you whether or not it failed the whole thing or it's a partial failure. And then for the next activity, you can just have a rollback process that will do nothing. If the input is successful, you do nothing. Otherwise, you do the rollback. That's potentially something you could do, but it's also easy to add support for rollback because ultimately that's just another thing you could do. That's where the sort of branching condition comes in, I guess. Yeah. Actually, talk to me afterwards. If you got that use case, I'd be quite interested to work on that again.
You can always add a callback for failure at each atomic action. Yeah. So if the atomic fails, not only fails, short circuits the rest, but also acts on the failure action, which basically rolls back at that level. There are a few patterns.
Yeah, there's a few patterns. The nice thing of having a service to do that is that it maintains the state for you, and you can do different steps from anywhere, rather than if the thing that's running the rollback blows up, then you lose that intermediate state that you have. Especially if those rollback process takes longer, it's not quite as immediate. That's what we do is the library also has got a number of events you can hook into, so you can also do it at that point as well. I think that's what we are doing. What we were doing in my last place where we were doing the ETL. So if something failed, we would just one of the events on the workflow object itself would get fired, so that you can then either at that point kick off another workflow or to just do the rollback there. So actually, maybe that's something you can do already.
Yeah.
Any other questions? All right, if not, then let's move on. Anything from the...
There was just a comment on that last question saying if you have workflow activities, don't distribute your transactions, write compensating actions instead. But I think we touched on that because that's one of the... That's basically
what the... I forget your name, but... that's what basically what John
it's from Roland Kuhn. It's I don't know, Aka person.
Okay.
There's a talk recently that he explains his models.
Yeah, I think that's also what you find in the saga pattern as well. The saga.
Yeah, that's the saga. That's exactly what I was talking about.
Yeah, that's the saga pattern where you do compensating actions instead. But
that definitely sounds like the sort of thing you don't want in a distributed transaction. There's just too many non-running things there. Right.
Yeah, depends. But I don't really like the saga pattern. It just written how easy to implement. Because for me, whether or not to use simple workflow, that's more of an implementation question rather than is the approach. Because you can do the same approach with the service or with something else. And Katie McCarthy, she was talking about the saga pattern, I think, at Change Loop this year, and she's working at Twitter now. I think they use it at Halo. I don't know in terms of how they execute those actions and compensating actions. It's a question of where do you implement them and how to make sure that those actions can be performed in the same sort of robust and reliable way. Those compensating actions can be performed in the same robust and reliable way as your sort of original actions, because ultimately anything can fail. You can quite easily get into where you got these transactions. It's a really bad problem because you can get into a case where your rollbacks are failing constantly for an infinite amount of time because the service could be down. What we're going to do is it's the same problem that I see in a lot of when people using DynamoDB in the same way that they try to do relational databases, where you've got this concept of transactions and try to replicate it to the world where DynamoDB you got different tables and trying to do transactions across them. And when things fail, you try to roll back, but then you end up running into problems such as your super requirement being exceeded because all of a sudden you flood the database with all these rollback actions, and then, okay, what are you going to do when the rollbacks keeps failing? And you end up with some inconsistent state that you have to deal with later on. So there's all kind of weird questions that, not weird questions, but a lot of questions that I need to answer. So the best thing to do would be to just not have those distributed transactions at all. But depends on the problem that you have. You may not be able to avoid it. Okay, well, let's move on then. And I'm jump here. So the last case study I want to go through is with Amazon CloudWatch service, which is a monitoring service that comes with Amazon Web Services. It collects metrics from your EC2 instances as well as the different services that Amazon provides. And you can also publish your custom metrics from your application. And this is where you go and find out the CPU utilization level, network in and out from your instances, or you can also overlap the graphs and you can plot graphs and overlap them from the management console. It's one of the very fundamental services, part of the Amazon ecosystem. But there's a number of shortcomings. The first one is that the granularity of the data is not that great. The smallest granularity you get is 1 minute, which means in terms of your time to discovery of a problem and your time to react to that and recovery is you're measured in maybe 10 minutes, 15 minutes. Whereas if you get much more granular data, then your time to discovery of a problem is much shorter. And that's one of the things that the Netflix guys have been working very hard. They've been building their own telemetry platform where you can get you can handle large volumes of metrics and a very granular level. And here at Just we use StatsD, and we're collecting data, I think, at the 10-second intervals, which means if you see a number of intervals where there's some data that the paper, say for example, the number of exceptions is spiking, then you find out within a minute that there's definitely some issue going on, rather than having to wait for 5 minutes, because if you just one spike, it might be nothing. But if it's something that stays for a few number of data points continuously, then there's a good chance that something is happening. But both services also have the same problem, being that once you've got enough metrics, it just becomes really hard for you to find anything unless you know what it is you're looking for. So the chance for you to discover upon some interesting, useful metric as when you're trying to investigate a problem becomes smaller and smaller, because the sheer number of metrics that you've got. I think we've got something like tens of thousands of metrics in the StatsD, which means unless you know exactly what you're looking for, you have a fair chance of finding the thing that's of interest to you. Ultimately, we are lacking the ability to find correlation between metrics. For example, if your payment service was slow yesterday, chances are it's because the database is being slow, or there's some other service that it depends on. Maybe your PayPal service, maybe PayPal is slow, or Facebook, or whatever payment provider that you're working with is having a bit of a blip in the latency. It's down to you to then go and dig around and look for the right metrics that can tell you and help you answer those questions, because none of these services provide the ability for you to find correlations between spikes in CPU with spikes in latency and between different services, which is why having to manage and maintain all the services that I built in the past, and having to do a lot of this work myself, and being it's very labor intensive and also just really boring. I just ended up writing in a small project which allows you to capture queries like 5-minute metrics whose 5-minute average was more than a second any time over the last 12 hours, and express that with either an internal DSL that's very humanly readable, or as an external DSL which does the same thing but with a slightly more English-looking syntax. So, for example, if I want to find if any of my cache nodes in my Elastic cache cluster had a CPU spike, I can do something like this, where I can use a regex against the namespace for the metric, as well as the name of the metric, and also to check if any of the data points was greater than some number. All right, so with CloudWatch, every single metric you get has got a namespace as well as a name, but it also has got different dimensions as well. So this library also supports querying against the different dimensions if your metrics have them. There's all in all, there's about 15 different operators you can use based on what is supported on the Amazon CloudWatch. For this particular query, for this DSL, I decided to not use a parsec instead, and just write vanilla F# using active patterns. So, is everyone familiar with active patterns? Okay. Does anyone want a quick primer on active patterns? Okay, right, a few hands. So before we start, let's just break down like a typical query. You've got a bunch of filters, which filters on the metrics namespace or name or whatever unit or some stats value, and then you also have a time frame that tells you how far back or what particular time frame you're looking for, as well as the granularity of the data that you want to query. And you can capture all that information in a very simple query object, which contains a filter, a time frame, and optionally a period, which is granularity. If you don't specify it, the service will just use 1 minute instead. The idea is that I want to take both the internal DSL and external DSL and get the query object back from both of them. So we know we want to filter on namespace and name. So first thing I'll do is I'll create a little type, a union type there at the top to represent the different metric terms, either namespace or name. And I've got a filter union case here, and I've just add one case which given some metric term takes in a predicate so that I can apply to a metric. I can apply to a predicate against either the name or the namespace. And since we know we want to filter on unit, I'll just extend my union type for filter to have another case that handles units. And the same with different stats points, which can be average, mean, max, sum, as well as count. And given each of one of these guys, I can also take another predicate to filter against those stats points. And because we want to combine different filters together with AND, I can just make the filter type recursive. So you can combine arbitrary number of filters by just turning two filters together into a composite filter instead, so that you can just have one type to represent all the different cases that you have. For the time frame, I want to be able to support anything for the last, say, 12 hours, or any time since or since a particular date time, or between two date times. And period is just a wrapper around the time span. So a quick primer on active patterns, which allows you to. So it's a language feature that allows you to abstract away patterns and give names to them so that they can be reused and composed together when doing pattern matching. You've got three types of active patterns. You've got the single case pattern where you can say, which kind of acts very similar to a function, where you put the name of the pattern in what we call banana clip operators. I don't know if you can visualize that, banana clips. In this case, this is a pattern that takes a string and returns a float. So whereas I'm doing pattern matching, this pattern will be applied for each of these cases in turn. And the thing that I'm pattern matching against becomes the input to my pattern. And the output of my pattern is bound to these guys here. And here I'm applying another pattern matching to say if the return value from that float active pattern is 42, then this line will be executed. Otherwise, if it's 11, then the second line will be executed. Otherwise, I can also just bind it to another local variable, which can use on the other side of my pattern matching. But the problem with this single case pattern is that where you're giving something that's can't be pattern matched at all, it will just error in this case. And sometimes you do want to be able to handle partial matches, so that's where partial patterns comes in. And the only difference, as you notice from the single case, is that I've got a second case here, which is represented with underscore, and this pattern will return take a string, and instead of returning a float, and you return an option of a float instead. So where I'm not able to pass the input as a float, I will return a none. So now, So now to the example that we had earlier, if we were to parse it successfully, so if the pattern returns some float, then the same thing happens as before. Whereas returns a none, then this guy is a wrong match, and we've got a cache all case at the bottom there. And the last type of active pattern you have is a multi-case pattern, where what you're doing is you're taking an input and imagine you're implicitly defining a union type to represent all the different cases or the different baskets you can take that input and put it into. So it allows you to take input space and slice it into different slices and have a case that represents each of those different baskets. So in this case, where the input is can be passed as a float, and then it's also a prime number, then we return the prime case with that number. Otherwise, we can pass it, but it's not a prime, so we return the not prime case, or it's not a number. So now, where we can do the same thing as before, we can use different patterns to handle different cases, and we can also combine different patterns together. Here we are using both and or semantics. So where the string is a float and is a prime, and that number is 11. Well, we can actually combine this together as well. Then we execute something. Otherwise, if it's a float and it's 42 or it's 8, then you do something else. You can also nest different patterns together, because the prime pattern takes a float, and we can apply another active pattern against a float. In this case, to check whether or not if that number is palindrome, which is going to give you a power prime. You can do a little Project Euler, you know what that means. And we capture that number, that float, as n, which you can use on the right-hand side of the pattern matching. So that's a quick primer on the active patterns and how we can use it to write parsers. First thing we're going to do, this is the typical common approach when it comes to writing parsers with active pattern, is that you tokenize the input into a list of strings. So in this case, input that we had earlier becomes a list of the keywords that we've got. And remember, list in F# is a linked list, so every item has got the item itself as well as a pointer to the rest of the list. And you can construct a list using the const operator, and it's the same as you can also use the const operator as part of your pattern when you do pattern matching. And this gives you the ability to pattern match against the structure of a list. So now we can first, we can start by writing very simple parsers that will match a string based in a case-insensitive way, or match it against as a float. We can also write parsers that match against the as an empty string, or string to start with or end with a particular character. And we can compose those guys together to have an active pattern that can take some input and returns and matches if the input is a string that's quoted with single quotes. So now we can have a pattern that says, okay, given some input, a list of tokens, if the structure looks such that the first element is a string that looks like namespace is, in case insensitive, and the second element is a quoted string, then we will capture the thing that's in between the quotes, and we will also capture the rest of the list as well as a variable. And in this case, we match it and we return a metric filter with that namespace value as well as the rest of the list. So this allows us to take that input, match it, and grab the different parts, and then construct the metric filter of the filter object at the end of it. And because we've captured the rest of the tokens, it means that we can then apply different patterns to the list recursively, and every time each of these patterns will return a filter that's been matched as well as the rest of the list. So then we can check If the rest of the list starts with an AND keyword, then we recurse whilst adding the filter that we've passed out to an accumulator, so that we gradually collect more and more filters whilst we consume the tokens from the list of tokenized input. And at the end, if there's no more AND keyword, then we just flatten out those guys, turn the list of filters and flatten down into a composite filter. And you can apply, whilst we also return the rest of the tokens that we haven't passed, and then we can then pass that on to the next part, which will pass the time frame and pass the period, and how we can iteratively construct a query object at the end of it. So it's a bit more work, but it's still quite easy to write. I wrote the whole thing, both internal and external DSL, in like 2 hours, which was great because I started at 2 a.m. and by the time I finished, I could barely see straight. With the internal DSL, you can run it anywhere where you can run F# code, which could be in your application or in the F# repo, which is what I tended to do quite a lot. And with the external DSL, it's great for writing tooling, so that you can have I've got a CLI tool that I can use. I can distribute via Chocolati, and I can write the query in the external DSL syntax and execute it, and basically just let the machine do all the work and figuring out finding correlations for me, and then plot a graph. So to recap, we looked at the CloudWatch and as example of impedance mismatch between what the service can do versus what are some of the things you need to do in the wild, and how this impedance mismatch renders routine post-mortem investigations into an exercise of finding a needle in a haystack, and how you can use the DSL to make that needle a little bit easier to find, at least. And just to sort of tell you some of the execution side of things, because of the way the service works, once I've captured the query request, the query object, I have to first make a bunch of requests to list all the metrics so that I can apply filters on the metric term, the namespace, and then make second batch of requests to get the data points so that I can apply any filters I have on the stats, and then I make and then collect the things metrics that matches my matches those filters, and then sort of show them at the end and plot a graph with that. And that's something that I was doing basically by hand, by going to the management console, list all the things, and one by one click a bunch of metrics, and then see if any of the data points are are spiking at the same time as the problem that I'm investigating. So rather than doing all that work myself, let's try and use computers to do all these things that we shouldn't be doing as humans. And that concludes a little case study. Oh, any questions on the last one? Yep.
Why would you use that approach rather than Parser? Just because you need the internal DSL as well?
Right. So the question is, where would you use the active patterns approach rather than using a parsec? I would say active patterns are quite nice for something really simple. And I started off thinking this was going to be really simple, but actually in the end, if I were to do the same implementation again, I'll probably use something like mParsec. But there's those examples where you're doing something very, very simple, and using a parsec just seems a bit of overkill. I would say I don't have a sort of rule of thumb or a fast rule on when to use it and how complex the DSL has to be before I make the jump to use a parsec. But usually it's based on my intuition on it is really simple. If it's anything more than trivial, I'll probably end up using a parsec or mParsec. Depends on whether or not I can depend on the external library.
In terms of timescales, how long does it take to write each one, roughly speaking, like to compare?
It really depends. For fparsec, obviously there's a bit more time involved in learning the API if you're not familiar with fparsec. So there is a learning curve there, but once you get a hang of it, it's really, really productive. Whereas with active patterns, you don't really have that learning curve because it's just a built-in vanilla F# function feature. So, well, like I said, it took me less than 2 hours, even both the parser, internal DSL, as well as execution side of things, So you can be very productive with either approach. See, but really, it really depends on depending on the DSL that is built, and also how much time you're able to invest in learning the API for Parsec. So that's a one-off. There is a one-off investment in learning there, as far as the Parser is concerned. But it pays for itself very quickly. Any other questions? Cool. Okay. Anything from the?
Nothing at the moment. So.
Cool. So that's everything I've got, and I just want to say that Justy is hiring, as I mentioned before. Thank you very much.
We do have a question actually.
Okay.
Do you have any concerns using AWS exclusive features? The Parsegate event has many worried about exclusive offerings. I've heard of Parsegate.
Parsegate.
Yeah. P-A-R-S.
So I can jump in since it's my question.
Okay.
Yeah, good for it.
So Parse was a infrastructure-free sort of offering where you basically sort of like AWS Lambda. You could put in some back-end code that would run on other infrastructure, and Parse was then acquired by I think Facebook and is now being thrown away. So a lot of people are trying to figure out what to do.
Oh. Yes. Yes. Right. So that's actually one of the that's my wish list for 2016 is to have .NET support on the AWS Lambda. So I guess your question is there any risk in the tying yourself to AWS? Is that the question?
Yes, that's right.
Yeah. I mean, personally, my view is that I've seen people try to do be too worried about a vendor lock-in and end up with the least denominator between all the different service providers. But that's just gonna leave you in a world where you can't take advantage of any of the platforms. There's certainly a certain amount of things that can't be shared, that can't be ported from one provider to another. Things like database solutions, and but otherwise for pure compute, the things that you use for virtual machines for, those you can still migrate from one provider to another. I personally wouldn't worry too much about the vendor lock-in. Chances are AWS is going to be around for much longer than any company that I work for. Except Just Eat, of course. Right now, also, there's we at least in my last place, we were using both Amazon Web Services and Google App and Google Cloud Platform very heavily for different things, depending on what it is that we're trying to do and which platform has the best offering for that particular need that we have. You end up paying a bit more on the data transfers and I/O, but in terms of the productivity gains you get, until you reach a certain scale, it just wouldn't matter. That becomes a cost concern. Which, if you're doing things well, doing things fast, then you should be making more money as a result. And those concerns just won't factor into the equation until you hit a certain big enough a scale. Like if you're a Facebook scale, that's different. Any tiny bit helps because anything you do can be translated into millions of dollars, if not more. And the same goes to Google and Microsoft. But for most people, it just really wouldn't matter. Or with AWS Lambda, sure, that's probably the most ultimate form of vendor. But at the same time, if you can save yourself days and weeks of development time by using AWS Lambda, then honestly, why not? If you have to reinvent it again because you want to move your workload from one provider to another, then okay, tough. You don't have AWS Lambda. You have to do a lot of work. But why? If AWS Lambda is there, why not take advantage of it? Ultimately, time to market is probably the most important thing as far as business is concerned, and also for developers, being able to do more with less people, that's also very important. And I think anything you can do to make your developers more productive, vendor lock-in shouldn't be the thing that's stopping you from taking advantage of those offerings. That's my personal view anyway.
Thank you.
It's not to say there's no risk. It's of course a risk, but I think it's a risk worth taking. Anything else? Okay, got any question?
Are there any other options for making external DSLs?
You can use regex, you can use all kind of other stuff as well, but from what I've seen, the most common approaches is to use fparsec or to use, use a parser combinator library, fparsec being the most popular one, or to use active patterns. You can, of course, depending on DSL you're working with, if it's something very simple like I don't know, comma separated values, then you can also just use a string split and do something with that. But using active patterns to match the different cases, it really depends. But those are the two most common approaches. Yep.
So with the last one, you obviously had the problem that you made DSL so you can get your metrics better.
Yep.
How in general, how hard does the problem have to be for its work making DSL? Is there an answer to that? Or?
I don't have a sort of rule of thumb for that, but for me, if it's something that, okay, so to go back to a book that we're right now reading in the sort of Justice Book Club, is the Growing Object-Oriented Software by Steve Freeman and Ned Price, and one nice quote from that is that as humans, we can only deal with complexity by hiding it. So for me, if it's something that I want to write code that can easily understand, and someone else can easily and really understand what it is that I'm trying to do. If I can't do that with a sufficient level of succinctness, then that's when I start thinking about whether or not it's worth using doing a DSL for it. A lot of it is me mentally imagining what would such a DSL look like. How would it be more expressive if I was to be reading code that's reading in the DSL versus reading code that's just doing things by hand, and whether or not it's external or internal DSL depends on whether or not I needed to, for example, run from both C# and F#, and can I use language-specific features, or whether or not there are things that I can't, whether or not I can express my intent sufficiently with types. If I can, that's great. If I can't, then maybe external DSL is the way to go. And tooling also comes into the question whether or not I need a command line tool to do things, or can I just be happy using F# and maybe even type provider in the repo. There's a number of things that factor into a decision on whether or not to write a DSL and whether or not to do internal or external one, depending on the need. But for most of the examples I've shown, they're all things that I have had a lot of pain dealing with for a long time, and then eventually one day I snapped, and this last straw on the camel's back, and I ended up doing something about it. And turns out it's not a lot of work. And because of the productivity you can get, it's also worth sometimes just investigate, do it. If it doesn't, it's not any value, throw it away. Shouldn't be afraid of writing code and that you just throw away if it's not worth maintaining or worth using. All right, so if no more questions, then I think peace should be on the way, at least for us in Bristol. Okay. All right, Ryan.
Thank you very much, Yan, and thank you all of you in Bristol for letting us join in.
Cool. All right.